You hop online every single day, stream shows, send emails, scroll through feeds, maybe work, maybe learn something new. It's just always there, right? We totally take it for granted. But have you ever stopped to think, like, who actually keeps this whole thing running? Who built it? Who's maintaining this massive global network we all depend on?
It really does feel a bit like magic sometimes, doesn't it? Just this, invisible utility. But when you start peeling back the layers, wow, it's this incredibly complex web, physical stuff, organizations, constant effort.
Exactly. And that's what we're diving into today. We've gone through the sources you shared, and we're pulling back the curtain on the internet's, hidden foundations. We're going to look at its surprising history, the actual physical kit that makes it work, the groups that shape and govern it, and the really big challenges now and, down the road.
Yeah, our mission here is really to uncover those unseen forces, those complex systems, trace how it grew from those early experiments, figure out who's actually doing the upkeep, and look at where things stand now, the challenges, the future. You're definitely going to find some surprising bits of info, get context that goes way beyond just clicking a link.
Okay, let's start right at the basics. What is the internet, really? It's not like one giant computer or something, is it?
No, definitely not. And that's probably the most important thing to get straight. The internet isn't one single thing. It's fundamentally a network of networks.
A network of networks. Okay.
Think of it like a global collection of separate road systems. But they all agree to drive on the same side, use the same signals, so cars can get from anywhere in one system to anywhere else.
Ah, okay.
These individual systems, technically they're called autonomous systems, or AS. Each one is managed by someone different, an ISP, a big company, a university. And they all agree to connect using standard rules, standard protocols.
Yeah.
The big one everyone knows is TCP/IP.
So, my home Wi-Fi connects to my ISP's network, which connects to a bigger regional network, which plugs into an even bigger one.
Precisely. It's layered. And because it's all these independent networks just agreeing to link up, no single person, no single company owns the whole internet. It's kind of collectively owned. Its existence depends on all these different players, your ISP, giant backbone providers, Google, governments, universities, all agreeing to connect and play by the rules of those protocols.
And these aren't all the same kinds of networks either, are they? The sources mention private, public, academic, business, government.
Absolutely. A huge mix. And they're hooked together with all sorts of tech, copper wires, wireless signals, but more and more, these incredibly high-capacity fiber optic cables carrying data as light.
Okay, that makes sense, this collection of different networks. But how did we get from just a few isolated ones to, this massive global thing? Let's trace that history. Where did it all start?
Well, the story usually kicks off with those early research networks in the late 1960s, like ARPANET. And a really key idea back then was packet switching.
Packet switching, right. Breaking data down.
Exactly. Instead of needing a dedicated connection like an old phone call, you break the data into small chunks, packets, send them off individually, maybe even on different routes, and the network puts them back together at the other end.
Okay.
This was revolutionary. Much better use of the wires, the bandwidth, and it meant computers running at totally different speeds could finally talk to each other properly.
And I read that idea actually faced some pushback.
Oh yeah, big time. Some established telecom folks were pretty skeptical. They worried about, the routers getting overwhelmed, running out of memory for the packets. Understandable worries at the time, maybe?
Wow. So something fundamental today was controversial then. It really was a different way of thinking, wasn't it? Moving from needing a perfect connection to letting the network just handle packets and the computers at each end worry about reliability.
That's a great way to put it. And that thinking continued with the core protocols themselves. The original idea from Vint Cerf and Bob Kahn back in the 70s, it described just one protocol, TCP, that handled everything transport, forwarding.
Okay.
But then early work on things like sending voice over the network showed that sometimes you didn't want the network trying to fix every lost packet. The application, like the voice call software, could maybe handle it better, make it sound less choppy.
Ah, so put the smarts at the edges, not in the middle of the network.
Exactly. That led them to split the original TCP. They created IP, the Internet Protocol, just for addressing and then sending individual packets. And then refine TCP for when you do need that reliability and flow control, like for file transfers. And they added UDP, too, for apps that wanted direct, faster access to IP without TCP's features.
That separation IP for delivery, TCP UDP for how it's delivered, feels really fundamental now.
It was a critical architectural choice. Intelligence in the hosts keep the network core simpler. It's shaped everything since.
And while ARPANET was developing, there were other networks popping up too, right? Mid-70s. Things like MFNet.
Yeah, quite a few. But many were purpose-built for specific groups. Fusion energy researchers, high-energy physicists. They often used different tech, weren't designed to connect easily. They were like islands.
So what started building the bridges? What really pushed towards this interconnected vision?
I think the really pivotal moment was NSFNET, the National Science Foundation Network, starting around 1985. The NSF built this high-speed backbone, connecting university supercomputing centers, then regional academic networks. And crucially, they mandated using TCP/IP.
And they had that rule, if you got NSF funding, you had to let everyone qualified on campus use the connection.
Yeah, not just the computer science department or whatever. Open it up.
And then there was that famous acceptable use policy, the AUP, banning commercial traffic on their backbone. That seems weird if you want growth.
It sounds counterintuitive, but it was actually quite strategic. By saying you can't run commercial stuff on our government-funded backbone, the NSF basically forced the private sector to build their own competing long-haul networks.
Ah, creating a market by stepping back.
Exactly. They wanted to stimulate a commercial internet. There were lots of discussions about this, called Comprev, starting around '88. It was a deliberate push.
That's fascinating. Government nudging the market. And the open standards were key too.
Absolutely essential. The fact that the technical documents, the RFCs, requests for comments, were totally open, meant anyone could grab them, use them, build compatible stuff. It fueled development everywhere, universities, startups.
And things like email helped develop the standards themselves.
Hugely. People could collaborate easily via mailing lists, hammer out ideas, write specs together. That's how the IETF working groups still largely operate today.
And bringing people together in person, like at that Interop trade show starting in '88.
That was massive. They basically told vendors, come show off your TCP/IP products, but you have to prove they work with your competitors' gear.
Forced cooperation.
Pretty much. Companies actually worked hard behind the scenes to make sure things were interoperable. It built huge confidence. And you saw the IETF meetings shift from mostly academics to mostly vendor engineers. Practical, implementable standards.
Then, early '90s, the World Wide Web arrives. Graphical browsers. Suddenly, it's not just for techies.
Exactly. That just lit the fuse for commercialization. Now, you weren't just selling network connections. You could build whole businesses on the internet.
Yeah.
E-commerce, online news, everything.
And the most recent massive shift.
Has to be mobile, right?
Oh, undeniably. The smartphone revolution. Putting powerful computers and constant internet in billions of pockets. That fundamentally changed everything. How we get news, how we shop, how we socialize. It made the internet truly, truly ubiquitous.
Okay, so that's the journey from experiments to global phenomenon. But let's talk physical stuff.
Yeah.
How is it all actually connected? What's the infrastructure look like? Right, it's this multi-layered thing. At the very top, you've got these monster fiber optic cables, the backbones crossing continents, crossing oceans. They link up massive data centers. Those connect to the ISPs who connect to regional networks, then local ones, then eventually, the cable or fiber coming into your house.
Still a network of networks just zoomed in.
Exactly. From global scale right down to your Wi-Fi router.
So what are the key pieces moving the data around?
Okay, you've got the backbone providers. They're the heavy haulers, managing those super high capacity long distance links. Think Chicago to Miami or London to Frankfurt. Then your ISP, your internet service provider. They're your direct connection, the company you pay your bill to. They connect homes and businesses.
Using different technologies for that last bit, right? The last mile.
Right, the access networks. Lots of ways to do that. Still some DSL over old phone lines, cable modems using TV coax cable. Increasingly, fiber to the home, FTTH, which is the fastest option. And then wireless Wi-Fi, cellular like 4G and 5G, and satellite, which is crucial for remote areas.
And directing all the traffic between these networks. That's the routers.
Yep, routers are the traffic cops. They sit at the junctions between networks. They look in the destination address on each data packet and figure out the best way to send it along its journey.
And the ones in the core of the internet must be incredibly powerful.
Oh, yeah. Core routers handle mind-boggling amounts of traffic.
They're connecting continents. Those cables under the sea.
The submarine cable systems, absolutely vital. They carry almost all intercontinental internet traffic. These aren't usually government things. They're typically built by huge groups of telecom companies, sometimes big content providers too, pooling resources because they cost a fortune.
Must be complex to lay them.
Very. need agreements for landing points in different countries, need the built-in redundancy, multiple cables, different routes in case one gets, snagged by an anchor or something. Development is still happening constantly.
And the tech inside those cables is mostly light, right?
Yeah.
Optical networking.
Yeah, optical networking is the key to high performance now. Sending data as pulses of light through hair-thin glass fibers. The physics goes way back, but companies like Optelecom really pushed commercializing it for telecom. Fiber means way higher speeds, way more bandwidth, over much longer distances compared to old copper wires.
Okay, so this incredible physical setup built over decades by countless different groups, who actually keeps it all running smoothly day to day? And the big question, who pays for it all?
Right, that's where it gets intricate. There's no single central bill. Basically, everyone pays for their piece of the puzzle. You pay your ISP. Your ISP pays bigger providers for transit access to the rest of the internet, or they make deals, peering agreements to exchange traffic directly with other networks.
And big companies like Netflix or Google.
They pay huge amounts for hosting their content in data centers near users and for delivering all that data. The costs are kind of embedded everywhere in all the services we use.
And it's not just companies. There are these important nonprofit groups involved, too.
Absolutely crucial ones like the IETF, the Internet Engineering Task Force. It's this nonprofit, pretty loosely organized international community researchers, engineers from vendors, network operators, users. They work together cooperatively to evolve the core internet protocols like TCP/IP. They publish those RFC documents we mentioned. It's a very unique bottom-up way of developing standards. Anyone can participate if they have the technical chops.
And then they handle the addresses.
Right. The Internet Corporation for assigned names and numbers. They manage the unique identifiers, the IP addresses that computers use, and the domain names like .com or .org that we use. They coordinate these globally so everything connects correctly. They're funded by fees from domain name registrations and IP address allocations.
And there was that big shift a few years back with the U.S. government stepping back from overseeing some of that, the INA transition.
Yeah, that was significant back in 2016. The oversight of the core INA functions, managing the root zone for domain names, IP addressing, protocol numbers, transitioned from a contract with the U.S. Department of Commerce to the global multi-stakeholder community itself.
So making it more international.
Exactly. It really solidified the principle that these core technical functions should be managed through cooperation between governments, the private sector, civil society, technical experts, everyone with a stake.
I remember some debates around ICANN itself, though, about how it operates.
Yeah, there have been discussions over the years about its accountability, its decision-making. For instance, getting rid of the directly elected at-large board members some time ago raised concerns for some about broad representation, though ICANN framed it as streamlining.
Okay.
But the INA transition itself was widely seen as a positive step towards globalizing oversight based on that multi-stakeholder model.
Okay. And the Internet Society, ISOC.
They're a global nonprofit, a charity, really. They advocate for keeping the internet open, connected globally, and secure. They do important work, like publishing reports on connectivity issues in different parts of the world, pushing for development.
And cybersecurity. We hear so much about that.
Yeah, the Center for Internet Security, CIS, is a key player there. They help organizations, governments too, manage cyber risks. They develop and share best practices, security benchmarks, ways to kind of measure your security posture and reduce your attack surface. Of course, individuals still need their own protections, 2 good passwords, maybe a VPN.
It really is this huge distributed effort, isn't it? A lot of work happening behind the scenes that we never really see.
Totally. It's constant collaboration, much of it pretty low-key, just making sure the plumbing works.
Now, beyond just the technical side, there's this whole area of governing the internet. It's moved beyond just protocols, hasn't it?
Oh yeah, much broader now. Internet governance covers a whole range of policy issues, economic, social, legal, that affect how the internet is used and develops globally.
And the approach for that is often called that multi-stakeholder model again.
That's the ideal, yes.
Right.
The idea is that decisions and discussions should involve input from all the relevant groups, governments, yes, but also companies, civil society groups, the technical folks, academics.
And there's a forum for that, the IGF.
Right, the Internet Governance Forum.
Mm-hmm.
It came out of a UN summit back in 2005. It's basically an ongoing global conversation. It doesn't make rules or treaties, but it's a space where all those different stakeholders can come together, talk about issues, share perspectives, try to find common ground on things affecting the Internet's future.
And speaking of policy debates, net neutrality came up in the sources. We need to be impartial here, but what did they say about the U.S. situation?
Okay, so the sources outline the U.S. debate. They mentioned the FCC looking at allowing potential FAF lanes back in 2014. Then in 2015, deciding to reclassify broadband as a telecommunication service, which gave them stronger authority to enforce net neutrality rules, preventing blocking or throttling of legal content.
But that changed again.
Yes. The sources note that legislative attempts were made, but then the FCC reversed course in 2017 and repealed those 2015 rules. It's clearly been a contentious issue with very different views on the right level of regulation.
Another governance tactic mentioned was internet shutdowns.
Yeah, unfortunately. Reports from groups like Access Now track instances where governments deliberately disrupt internet access, often during protests or elections, as a means of control.
Okay, let's shift to the internet today. What are the biggest challenges we're facing right now?
Well, a massive one is still the digital divide, just the basic problem of access. Large parts of the world, and even within developed countries, lack reliable high-speed internet, especially rural areas, low-income communities.
There were some stats in the sources for the U.S.
Yeah, an FCC map indicated something like 7% of U.S. households and businesses, which is around 8.5 million locations, tens of millions of people, still don't have what counts as broadband access.
And governments are trying to tackle this, like the BEAD program in the U.S.
It's exactly. The U.S. BEAD program is huge, over $42 billion from that 2021 infrastructure law. The stated goal is pretty ambitious. Connect every U.S. household and business to high-speed internet by 2030. It also aims to lower costs and encourage making the cables and equipment here in the U.S.
But even if the lines are there, people have to be able to afford it. And a big help just disappeared, right?
That's a really critical issue right now. The Affordable Connectivity Program, the ACP, gave eligible low-income households a $30 monthly discount. It was vital for millions, but it ran out of funding and ended June 1st, 2024.
That's gotta hurt.
Huge impact. Makes it harder for those families, obviously. But it also affects the ISPs, right? If a chunk of potential customers in an area can no longer afford the service, it makes it harder for the ISP to justify investing in upgrades or building out, especially in those already expensive rural areas.
And broadband, just to be clear, is defined as what speeds?
Generally, the benchmark is at least 25 megabits per second for downloads and 3 megabits per second for uploads.
Looking at the tech itself, fiber to the home FTTH seems like the goal, but getting it everywhere is tough.
FTTH is definitely the premium option. Much faster speeds, way more capacity, and it's kind of future-proof because you can upgrade the electronics at each end to push more data down the same fiber later on. It handles everything we do now, streaming, 4K video, gaming, remote work, all that.
But the rollout challenges.
Oh, yeah. Huge hurdles. Just getting permission to dig trenches or hang cables permits, rights of way can be slow and complex. Sometimes existing providers might resist new competition, and it's just plain expensive. The construction, the labor, the equipment, it's a massive investment. Plus, fiber itself needs skilled technicians for installation and repairs, finding breaks, managing signal strength.
Are newer technologies changing the cost equation or bringing more competition?
They definitely are shaking things up. 5G wireless, for instance. As it gets built out more widely, the cost per gigabyte of data is expected to fall, even though building all those small cell towers is expensive up front. It enables new stuff too, with lower latency. And then you have low Earth orbit LEO satellites, like Starlink.
Right, internet from space.
Exactly. That's a game changer, especially for remote and rural areas where laying fiber is just too costly. It can bypass the local phone or cable company entirely, potentially breaking up monopolies and forcing prices down, or pushing incumbents to finally upgrade their own networks. These satellites are seen as really key globally for bridging connectivity gaps, like in the Middle East, North Africa regions mentioned in some sources.
With everything moving online, cybersecurity must be a constantly rising cost too.
Absolutely.
Yeah.
It's not really an optional add-on anymore. It's a fundamental cost of doing business online. The risks are just too high. So companies have to constantly invest in better defenses. AI for threat detection, automated responses, training staff, keeping everything patched, protecting data. Following frameworks like those from CIS helps, but it's an ongoing, expensive battle.
And just the way we use the internet keeps changing, right? More video, more remote work. That must put pressure on providers.
Constantly. Think about the shift for remote work. Zoom calls all day, kids learning online, richer social media full of video. All of it demands more bandwidth, more stable connections. ISPs have to constantly monitor usage, predict trends, and scale up their networks to keep pace, trying to balance the cost of those upgrades with providing the quality people now expect and need.
And this all circles back to the economy, doesn't it? good internet means?
Better productivity, smoother business operations, new economic opportunities. Fast, reliable internet isn't a luxury, it's essential infrastructure now. When connections are slow or go down, businesses lose money, customers get frustrated, operations grind to a halt. The economic dependence is just massive and growing.
So tackling all this, the access gap, affordability, security, keeping up with demand, it sounds like it really needs everyone pulling together.
It absolutely does.
Yeah.
Government providing funding and policy frameworks, businesses investing and innovating, communities advocating for their needs. It requires real collaboration to make it efficient, widespread, and balance cost with accessibility.
You know, as we wrap up, something that struck me from the sources was just how hard it is to even document the internet's history properly.
Yeah.
Because it grew so organically, so decentralized, especially after ARPANET. A lot of it happened through emails and formal chats. The records are apparently really scattered, sometimes just gone. Makes it tough for historians.
That really underscores its unique nature, doesn't it? Not some top-down master plan, but this emergent collective creation.
Yeah. Which leads us nicely to a final thought for you, our listener, to maybe chew on. Consider this tension. The internet was built on these amazing principles of open standards, decentralized growth, collaboration. But now, we see increasing needs for more centralized security measures, debates about global governance, and this huge challenge of ensuring everyone gets affordable access in a world where giant commercial companies play such a dominant role. How do we balance those original ideals with today's realities? And what role do we as individuals play in shaping where this essential global utility goes next?
It's a really fundamental question for our times, I think. Affects everyone.
Well, this deep dive has hopefully shed some light on just how incredibly vast, complex, and collaborative the internet really is. Way more than meets the eye when you're just, scrolling.
It's definitely a constant work in progress. Technology, policy, human effort, all intertwined.
Thank you for listening to us. We really appreciate you joining us to explore these crucial parts of the internet story today.
Yeah, thanks for tuning in. Hope you gained some new perspective on what goes on behind the screen.
We definitely encourage you to keep exploring complex topics like this one. Be sure to subscribe to the channel to learn about different and interesting topics in our future deep dives.